All right, guys, so we are going to be learning about residual plots. And what residual plots tell you is they tell you whether the model, the regression model that you chose for a set of data points is a good representation of the data, or whether you need to look closely at your model and maybe find a different regression model. And we'll get to that. But first, we need to learn what a residual is before we talk about residual plots. So a residual is the difference between the observed y value and the predicted y value. So how you calculate your residual is you take your actual y value in your data set, so what the actual data point is, and you subtract your predicted data point that you would use when you use the linear regression model or the regression model. So I'll walk you through what it is by going through this problem. So we have a skydiver jumping from an airplane, and it has an attached microcomputer that records the time and the speed of the diver for the first 12 seconds of the diver's freefall. The data for this is shown below. And Roberto sees this data, and he decides to use a graphing calculator to determine the linear model for the data below. He calculates the linear model to be y is equal to 6x plus 13.1. Now, Eduardo does not believe that Roberto should have used a linear model to represent this data. So we're going to help Eduardo prove and explain to Roberto why Roberto is flawed in thinking that this data should be represented by a linear regression model. All right, so we are going to first find the predicted y values or the predicted speed using the times that we have in our table above. So how we do this is we take our time and we put it in for x in our linear regression model. So I have a 6.0 times a 0 plus a 13.1. And when I do that, I can type that into my calculator, I get a 13.1. So that is my predicted y value. That is what the linear model predicts the y value to be when you have a time of 0 seconds. Now we're going to do the same thing for a time of 2 seconds. So 6, you don't have to do the 6.0 because 6.0 is the same as 6. So 6 times 2 plus 13.1. So if I do that in my calculator, 6 times 2 plus 13.1, I get 25.1. So what that means is that my linear regression model predicts that when the diver is 2 seconds in its free fall, it is going 25.1 feet per second. All right, now we're going to do the same thing for 4. I'm not going to write it out. A 6 times a 4 plus a 13.1 is a 37.1. So this is the predicted y value. Now we're going to do the same thing for 6. So 6 times 6 plus 13.1, I get a 49.1. And so forth. I want you to finish off the table. We're going to do it for 8. We're going to do it for 10. And we're going to do it for 12. Okay. So now, to find the residual, what we do is we take our actual y value on our data set and we subtract the predicted y value. So a 0 minus a 13.1 is a negative 13.1. So that's my residual. My actual data point y value, which is 25, minus my predicted, which is 25.1, and I get negative 0.1. All right, I'm going to have you do that for the rest. So 46 minus a 37.1 is an 8.9. 60 minus a 49.1 is a 10.9. 68 minus a 61.1 is a 6.9. 72 minus a 73.1 is a negative 1.1. And 74 minus 85.1 is a negative 11.1. Okay, so now what we're going to do is we're going to plot this on the graph below. This is called the residual plot, all right? And so we're going to make a scale on the graph. X's, we're just going to make our x's go, let's say, by 2's. So we're going to start at 0, and my x's are going to go by 2's. So 2, 4, 6, 8, 10, 12. I guess we could have went by 1's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, we have enough to go by 1's. So let's just go by 1's because my x's only go up to 12. So never mind. My y values, though, my y scale, we're just plotting the residuals. So my lowest residual is 13. My highest residual is 10. So maybe we go by 3's. And we'll just go off the graph a little bit for the 13. The residual plot does not have to be a super accurate plot. It can be more of an estimation. So I'm not worried about you going off the graph on the residual plot. All right, so when x was 0, my residual was negative 13.1. So at an x value of 0, my residual is negative 13.1, which would probably actually be not there. It would be closer to negative 12. So just kind of estimate where that's about to be. Remember, residual plot can be more of an estimation. When my x value is 2, my residual is negative 0.1. So remember, we went up by 1, or we went up by 1s on the x axis, and a negative 0.1 is going to be very close there. Oh, I'm sorry, I put that on 3. Okay, when my x value is 4, my residual is 8.9. Again, it can just be an estimation. We don't have to be completely exact. When my x was 6, my residual was 10.9. When my x value was 8, my residual is 6.8. And when my x value is 10, my residual is negative 1.1. And then finally, when my x value is 12, my residual is negative 11.1. Okay, so this is my residual plot. And it kind of looks like it has a pattern here. It looks like a parabola, all right? If you have a pattern on a residual plot, that is not good. That's not a good thing. What a pattern means is that the chosen regression model, in this case it was a linear regression model, that model is not a good representation of what the data reflects. In fact, if we look at this data, to me it looks more like an exponential model should have been used. But in order to determine whether the model was correct or not, we use a residual plot to help us figure that out. All right, so now after we showed Roberto visually why a linear model should not have been used, now we're going to explain to Roberto why a linear model, regression model, should not have been used for the data that was posted above. So the residual plot shows a pattern. A pattern means that the model chosen to represent the data is not a good choice. This data should not be represented by a linear model. Possibly an exponential model might have been a better choice. And that's it. Okay, we're going to move on to the next one. All right, a school district was attempting to correlate the number of hours a student studies in a given week with their grade point average. They surveyed 8 students and found the following data, and the school district decided to use a linear regression model, and this is the linear regression model that they came up with. We want to find the residual associated with the data point of 1194. So how we do this, we have a data point of 1194, so this is the actual y value. We first need to find the predicted y value by taking this 11 and putting it back into the linear regression model. So I have y is equal to a 1.3 times an 11 plus a 73.7. So if I do that, a 1.3 times an 11 plus a 73.7, we get the predicted y value to be 88. This means that if a student studies for 11 hours, the linear regression model predicts that the student's GPA would be 88. All right. Now the residual, because that's what we're asked to find right now, is the actual y value, the actual GPA, minus the predicted GPA. And that means 94 minus 88. That means that the linear regression model for this actual data point is off by 6 points. Remember, a linear regression model or any regression model is just an estimation of, let's say, another student studied for 11 hours. Well, they might not or have a GPA of 94, but the model's predicting that they're going to have a GPA close to 88. That's why we have the linear regression model, to predict what the value could be for another student that studies 11 hours. All right, so now we're going to do, was the linear model the best choice to represent this data? So we're going to do another residual plot. So I'm going to put 3 into my linear regression model. 1.3 times 3 plus 73.7, we get a 77.6. I'm going to have you fill out the rest of the prediction by pausing the video and completing the chart. Okay, so these are all the predicted y values. So a reminder to calculate the residual, we take the actual y value or the actual GPA minus the prediction. And for this one, we get 0.4. Now I'm going to have you fill out the rest of the chart for the residuals by doing the same thing for each of the points. All right, so here are your residuals below. Now we're going to do a residual plot. It looks like my x values, the highest x value is 16. So let's make our x-axis go by 2's. Okay. And my residuals, the lowest is negative 2.8. My highest is 6. So we can also go by 2's, but that should be enough. 2, 4, 6, 8, 2, 4, 6, 8. And now we're going to, negative. Now we're going to just create this residual plot by estimating. I want you to pause the video and do the residual plot on your own. A couple of things, the x values do not go in order, so make sure you are plotting the residuals in the correct location. And then also, since the residual plot does not show a pattern, a linear model was probably the most appropriate choice for this data. All right, check your model, and that's it for today.